Hello, welcome to my YouTube channel. My name is Nenye Abraham, and I want to kindly plead with you to subscribe to this channel if today is your first time on visiting this channel. Before we start with our lesson, I would like to say that God bless you so much for listening to my teachings, and um, I pray that you understand even as we continue to learn new things. Today we are learning three set problem. We are learning three set problem, and we are specifically looking at regions in three set problem and their allocated names. The regions in the three set problem and their allocated names. So the three set problem, I assume that we all know up to the point of drawing a Venn diagram. We know up to the point of drawing a Venn diagram. So when you are able to draw your Venn diagram like this, so this is for set A, and this is for set B, and then this is for set what C, and you are supposed to what solve this. So every region here has a name you call it, or if you say that name, everybody knows that, then you are talking about what? This region. You are talking about this region. You are talking about this region. So we are coming to look at those regions and their allocated names. When you say them, people know that this is the region you are talking about. I realize people would have understood this topic if they know the names of the regions, because anything they will ask about three set problem is talking about one of the regions in here. In here, it's talking about one of the regions in here. So there's a need that you understand the regions and their names. So we are first starting with the first region, which is, I named region 1, which is R1. R1. I named it in the this thing as region 1. Now region 1 is here. This is region 1. Now you see that this region is the intersection of all the three circles. All the three circles intersect at this region, and so we call this region as A intersection B intersection C. This is A intersection B intersection C. That is our first region. A intersection B intersection C. And our second region, region 2, region 2, which is this region we see here. Region 2. Our region 2 is A intersection B intersection C complement. A intersection B intersection C complement. Or you can also say that A intersection B only. Now this region, the region 2, is the region I've shaded, and that is A intersection B only. A intersection B only. Our next region, region 3, I am shading it with round circles. So region 3, our region 3 is A complement intersection B intersection C. This region here. which I've shaded with the smaller circles, is A complement intersection B, or you can also say B intersection C complement. Sorry, B intersection C only. B intersection C only. Then our region, next region, which is this region, this region here, region 4. Region 4 is A intersection B complement intersection C, or A intersection C only. A intersection C only. Then region 5. Region 5 is here. Our region 5 is called A only, or only A, or you can say A intersection B complement intersection C complement. In that way, we'll take it as what? A only. Only A. Then region 6. Region 6. Region 6 is here. Our region 6 is, you can say C only, or A complement intersection B complement intersection C. That is our region 6. And region 7, region 7 is what we call B only, or A complement intersection B intersection C complement. Then our last region we are looking at is region 8. Region 8, this region, and region 8 is this, the whole of this, the outer part of the circles are the region 8. We call that region A union B union C, or complement. Or you can also say neither A neither A B nor C. Neither A, B nor C. So these are the names we can. So there are some 3 regions I want to talk about. This region, region 2, region 3, and then region 4. These regions, they can also be called A and B. So for this region, you can say that A and B, but not C. It means that they are talking about this region. Please be careful about this. If they say A or B, but not C, it's a different thing altogether. A or B, but not C. It means that A or B, but not C. It means that if you take C away, what is left? So if it is A or B but not C, it is different from A and B but not C. They are two different things. So this region can also be said as B and C but not A. And then region 4 can be said to be region 4, A and A and A and C, A and C, but not B. Please, I hope you are following. And after that, we'll look at region 1 and 2 combined is called A intersection B. A and B, or you see them say both A and B. If you see both A and B or A intersection B, it means region what? 1 and 2 combined. This region 1 and 2 combined. This region combined. And then R and R3 combined. This region, this whole region here, this and this region combined is what we call B intersection C. And likewise, this region 1 and 4 combined is what we call A intersection C. A intersection C. Please, I hope you understand. And this is a simplest way to understand the three set problem. This is the simplest way. So I was talking about them talking about A or B, A or B, but not C. A or B, but not C. Look at this. A or B, but not C. So it means that you take the whole of the C circle out. What is left is what? Region 5, region 2, and region what? 7. Region 5 plus region 2 plus region 7 is what they are talking about if you hear this thing. Now, if you hear A or C, but not B, it means that you take the B region out. What is left is region what? 5, region 4, and region 6. So region 5 plus region 4 plus region 6. This is it. This is it. As simple as that. As simple as that. But the last things I'm calculating or I am saying, I didn't include. I am talking excluding region 8, assuming that there's no region 8. If there is region 8, there's a way to go about it. This is it. This is it. So the last thing we will learn and then end this lesson is the De Morgan's De Morgan's law. The De Morgan's law states that A A union B union C is equal to number of what A plus number of B plus number of C minus number of A intersection B plus minus, you are subtracting the three intersections, A intersection C and minus number of A B intersection C plus number of A intersection B intersection C. Then if there is the outer region, this region which we said it is called A union B union C, all complement, then you add it. If it is not there, there's no need you add it. This is the De Morgan's what law. The De Morgan's law. Now let's say that this formula can also be written in another form. There is another way to write the De Morgan's formula, which can be written this way. De Morgan's. So the A union B union C, number of A union B union C is equals to, maybe you pick one of this number of A. If you pick number of A, the whole of this circle, what is left should be this. So it will be number of A plus region 7 plus region 3 plus region 6. So assuming I didn't pick number of A and I pick number of B. Number of B means that it will be the whole of this region. So what you'll be adding is this region, and this region. Or if you pick number of C, which is the whole of this circle, if you write number of C here, the next thing to add will be this region, and what? This region. As simple as that. So that is what we are supposed to know about this topic. And this brings us to the end of our lesson. Thank you. Kindly subscribe to my YouTube channel if today is the first time of visiting this channel. Thank you.